Hello and welcome back. The moment has arrived. We are at the final video in graphing rational functions. It is time to perform sign tests and then use those sign tests to plot our graphs. All right, so let's take a look at our journey so far. All right, I feel like there should be like montage music playing or something. Here we go. We fully factored the numerator and the denominator. We found our x-intercepts, our y-intercepts, and our holes. And today we're going to take that information about holes and we're going to figure out exactly where to plot that hole. Okay, we took a look at multiplicity and how it tells us what happens on either side of an x-intercept. We found our vertical asymptotes. We found our horizontal, oblique, or sometimes no asymptote. And then right now we're going to perform a sign test. We're going to then use that information along with all the information to actually graph. All right, let's get right into it and perform a sign test. All right, here's our first example. So what is a sign test? A sign test allows us to figure out in each of our intervals. So we have an asymptote here. So we have a first interval from -infinity to -4. We have a second interval from -4 to our y-intercept there, so 0. We have an interval from 0 over to our x-intercept at 3. We have an interval from 3 to our next asymptote, -4. And then we have our +4, and then we have an interval from +4 to infinity. So what we're going to do here is we're going to go ahead and just make a line. All right, so over here we have -infinity, over here we have +infinity, and then we're going to plot our interval points. So we have our -4, we have our 0, we have our, well, that should be a little bit more over here. We have our 3, we have our 4, and then we have +infinity. All right, so what does it mean to do a sign test? Well, to do a sign test, we're going to go ahead and pick a number in each interval. So -infinity to -4, maybe I'm going to go ahead and pick -5. And then I'm going to check out what happens in my function. But I only need to care about positives and negatives. I need to know if it is above or below my axis. So when I put -5 into my numerator, -5 minus another 3, that makes my numerator negative. When I put -5 into a squared term, that pops out +25. And +25 minus 16, that gives me a positive in my denominator, and a negative divided by a positive means in this whole interval, I can expect to have negative numbers. Okay, now I'm going to check something out in my -4 to 0 range. So maybe I'm going to go ahead and plug in -1. And we do it again. -1 minus 3 gives me a negative on the top of my fraction. -1 squared is 1 minus 16. That still ends up negative on the bottom. So I can expect in this interval, I will cross the axis and things will be all positive. Okay. From 0 to 3, I'm going to maybe try out the point 1. 1 minus 3, that's a negative on the top. 1 squared is 1 minus 16, that's a negative on the bottom. I can expect in this interval, things remain positive. 3 to 4, okay, maybe I'm going to try 3.5. 3.5 minus 3, that's a positive on the top. And 3.5 squared, well, I'm going to sort of in my head go, I know 4 squared is 16, so 3.5 squared is less than 16. And less than 16 minus 16 gives me a negative on the bottom. So I can expect in this interval, I will be in the negative range. All right. And then 4 to positive infinity. Okay, maybe I'm going to try 5. 5 minus 3 gives me a positive on the top. 5 squared, 25 minus 16 gives me a positive on the bottom. And I can expect in this range, I will be positive. So now I am going to take this information and I am going to put it into my graph. So over here in the negative infinity to -4 range, I can expect things to be, up here, I can expect things to be negative. And since I've got an asymptote there and I've got an asymptote there, I can expect that range to look something like that. And if I want more specific, I can actually plug points in with my calculator to get a couple of points, but this is the general shape it's going to be. Okay, now from -4 to 0, things are positive. And I also know I'm anchored by that point right there. So I can expect things to look like that. And see, I'm approaching this asymptote and I'm heading down to this point. All right, now in the 0 to 3 range, things remain positive. So I'm continuing on to that point. And now in the 3 to 4 range, things went negative. So there's me approaching that asymptote. And then finally over here in my 4 to infinity range, everything's positive. So again, I'm coming down from that asymptote and being bounded by that asymptote. And you can see how important the asymptotes are. And that is my picture of that rational function. My x-intercept, my y-intercept, my vertical asymptotes, my horizontal asymptotes, my sign test, and my sketch. Woohoo! Okay, let's do it again. All right, here we are again. Let's make our sign line. All right, negative infinity, positive infinity. All right, let's do our points. So our first point here, 1, 2, 3. So this is our -3. Then we've got our asymptote here at 0. This isn't a very straight line. We've got another 0 over here at +2. And then we go off to infinity. So let's check our ranges. Okay, negative infinity to -3. I'm going to try -4. And I'm going to actually grab my factored forms because that's going to make my life a whole lot easier here. All right, so let's check this out on our factored form. So -4. So -4 minus 2 is another negative. And then -4 plus 3 is still a negative. Divided by -4 is also a negative. And a negative times a negative is a positive. Divided by a negative means in this whole range, I can expect negative. Let's do it again. In my -3 to 0 range, maybe I'm going to try -1. Okay, -1 minus another 2, that's a negative. -1 plus 3, that's a positive. -1, that's a negative. A negative times a positive is a negative. Divided by a negative, that's a positive. Okay, 0 to 2, I'm going to try 1. 1 minus 2, that's a negative. 1 plus 3, that's a positive. 1, that's a positive. A negative times a positive is a negative. Divided by a positive is still a negative. And finally, I'm going to try 3 over here. 3 minus 2, that's a positive. 3 plus 3, that's positive. 3, that's a positive, 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 that's a positive. All right, let's see what that looks like. So over here in this range, I can expect negatives. And then I know I pass through this point and it becomes positive at that point. So I'm bounded over here by this, and I'm going to extend that line for myself. All right, so I can expect to come from the negative, kind of bounded by this line, and pass through here, and then continue up and be bounded by that line. And that takes care of my negative in the 0 to -3 range, and then positive in the -3 to 0 range. Now in the 0 to 2 range, I'm back to the negative. So here I'm bounded by this line, and I pass through the axis. And now in my 2 on up, I'm positive, but I'm bounded by my oblique asymptote. So again, I can kind of expect to do that. And so that is a rough sketch. I could have made this curve a little prettier here of this rational function. I did my x-intercepts. I did my y-intercept, which didn't exist. I did my vertical asymptotes, my oblique asymptotes, my sign test, and I came up with my sketch. Let's do it one more time. All right, I'm making my sign. I'm putting in all of my points. So I've got my asymptote over here at -2. I've got an intercept at 0. I have a hole at 1, and I need to figure out where that hole is exactly. And then I go on to positive infinity. So let's start by finding out where our hole is. Well, how do we do that? We go up here. If we were to put 1 in, we would end up with a 0 on the bottom, which we can't. But because we have this factor, top and bottom, and this is what makes it a hole, not an asymptote. If we didn't have this on the top, then that would just be a straight up asymptote. We'd have a dotted line through. Because we have this on the top, it's essentially like those two factors cancel. And when we put 1 into what's left, 4 times 1 is 4. 1 plus 2 is 3. So at the point 1, we would have the value 4/3, except we don't, we have a hole. So 1 and then 4/3 would be a little bit above 1. So that's actually where our hole exists. We have this here as a placeholder to remind us, but that's where the hole lives, at over 1 up 4/3. Okay, let's do our sign test. So we're going to try -3. We can ignore these two because they will be the same and they will cancel. So 4 times -3, that makes a negative on the top. And then -3 plus 2, that's still a negative on the bottom, which means negative divided by negative, that's a positive in this range. Okay, over here, we could try -1. -1 times 4, that's a negative on the top. -1 plus 2, that's a positive on the bottom. A negative divided by a positive, that is a negative. In our 0 to 1 range, let's try 0.5. 0.5 times 4, that's going to be a positive. 0.5 plus 2, that's also going to be a positive. A positive over a positive is a positive. And then finally, in the 1 off to infinity range, let's go ahead and try 2. Whoops, sorry, 2 down there. 2 times 4, that's a positive on top. 2 plus 2, that's a positive there. That means in this range, we will also have a positive. So, and that makes sense because this is on either side of a hole. So we should be just continuing the same trajectory. We just have a hole there. So now we are all ready to graph. So we take a look in our range here from -infinity to -2, and we see that that's positive. So we're bounded by our horizontal asymptote there and our vertical asymptote there. And we're a little crunched here because of our sign test, but we can estimate that our graph in that range will look like that. Then we hop over to our -2 to 0 range, and we see that we are negative. So here's our asymptote here. Here's our point at 0, 0. So we know we are starting from the negative, bounded by this asymptote, and we are heading there. And that'll go on forever. Okay, then we take a look in this range from 0 to 1, we are positive and we're heading toward this hole. And then the other side of the hole, we are also positive. So we can continue our arc up to the hole, and we continue on the other side of the hole, and then we are bounded by our horizontal asymptote there, creating that half of the sketch. So this would go on to infinity, this would go down to infinity, this would continue on to infinity. We've got our hole there. All right, we have our x-intercept, which is also our y-intercept. We have our hole. We have our vertical asymptote, our horizontal asymptote, our sign test, and our sketch. All right. Well, it has been a journey, but you guys did it. And I encourage you to keep playing, keep trying, and then you can make up problems for yourself and then check them on your graphing calculator. So do all your good work, then go into your graphing calculator, type them in, take good care to put parentheses around your entire numerator divided by parentheses around your entire denominator. Otherwise, your calculator will be literal and you will not get what you want. All right, keep it up. There'll be another video soon where we do one rational function from beginning to end, so you can see the whole process all in one video. But keep practicing, and as always, keep mathing.